Chapter Part 2 about IP version 4 addresses. These different types of IP version 4 addresses can be used for different purposes. We have, first of all, the unicast, and we have the broadcast, and we have the multicast addresses. The unicast is a one-to-one communication where we send from one to one specific IP address. Then we have the broadcast. The broadcast is when we send from one device to all the others on a network. Typically, the broadcast is just valid on the local area network, so the routers will not send broadcast out to other destinations or to other networks that it is connected to. The broadcast address is always found by setting the host portion of the IP address to binary ones, typically ending with 255. So in this case here, where we have a network called 172.16.40/24, well then the broadcast will be 172.16.4.255. That will be an address that will apply to all devices on this network. We also have multicast addresses. Multicast is when we want to send to a group but not to all. It reduces the traffic because we will only send one packet instead of sending 4 or 5 or 10 or 20 or how many we have in a multicast group. So there are different IP addresses that are reserved for multicast groups. It's from 224.00 to 239.255.255.255. This is class D IP addresses. There are some that are local link or link local that will only apply to the local part of the router. For instance, 224 to 224.00255. But there are also global scopes that will be sent out to other devices, and for instance, different protocol have different multicast addresses. This is an example for the networking time protocol that can be used to align the time on different types of networking equipment. We have also private IP addresses. These are IP addresses that are never routed out to the internet and are only for private use only. Normally, we will use these addresses because we have one scope of IP addresses on the internal network and we have another one on the external part of the network, typically the ones connected to the internet. So in this case here, we have these three ranges of IP addresses that are private. It's 10.0.0.0/8, it's 172.16.00/12, and 192.168.00/16. They are only private addresses, never routed out. Yes. Then there are some special IP version 4 addresses. Apart from the network and the broadcast addresses, we have the loopback or the local host address, which is 127.0.0.1. It is a specific address, and it will also only all hosts will answer that themselves. Then we have the link local address, which is 169.250.400 and up to 255.255 in the end. It's an address that will be assigned to you if you don't find a DHCP server on the network. Then we have the testnet and we have the experimental addresses. So there are some addresses that we are not able to use. In the early days of the IP version 4, then we have these different classes. We have a class A, B, C, D, and E. And depending on the bit pattern on the first octet, then we can see whether it was a class A, B, C, or D. So the class A addresses were the ones where the subnet mask was set to /8. So this is normally the very huge networks with room for a lot of host addresses. Class B were a bit smaller, and Class C were the smallest network. But we will have a more in-depth look at this in class. The The classless addressing, where we don't really look at these classes anymore, is called classless interdomain routing, or CIDR. So here we don't really think about whether it is a class A, B, or C. We just look at the prefix, which means the subnet mask. On the internet, it is of course important that we don't use the same IP address again, because the IP addresses on the internet needs to be unique. So that is why we have these different local authorities that will also keep track on available IP addresses. We normally will just, use one network IP address locally, but sometimes, and most times, we would generally divide it into smaller parts or smaller subnets, and we will give these or different types of IP addresses. And the same thing actually applies on the internet. We have the large ISPs, which has a huge number of IP addresses, and then divide them into smaller parts so that they can hand them out to different parts of the internet. But the basic idea here is that all the addresses need to be unique. And that was it. I try again.